This video is the plan sheet video, goes along with the plans reading class. You can see we're going to talk about plan sheets now, and you'll see that we're looking down on the project. So we have our edge of pavement, shoulders, end conditions, our ground, and a vehicle on it. Rather large vehicle. Okay, the overview shows the view of the roadway from overhead as if flying over. Shows horizontal features such as curves and tangents. Shows all stations and offsets for right-of-way easements and driveways. Okay, so you can look at this sample down here. This is a roundabout with a highway coming in. So you got all this information. You're going to see north arrows. You're going to see scale bars down here. You're going to see that everywhere. You're going to see some stationing in here, which we're going to talk more about. Let's see what it says here. Standard plan sheet with title block stations, property owner, scale, north arrow, more. There's a lot of stuff to this, and usually these plan sheets are pretty loaded with some information. So this is just a looking down on the project. A full set of plans would look like this, where you've got just basically some edge of pavement out here, and then you got your end conditions, and you got your north there, you got your scale bar. But this is a full plan sheet, so you see one plan sheet in here. If we look at the next one, this is a plan sheet. This is where we could fit more than one plan sheet in here. So you got a top one, and it ties to the other side. So that's what they usually do. You can see the match line here, station 616 plus 08.48 matches up with station 616 plus 08.48. So this would go to the back side of this. But sometimes you got enough room that you can actually split them up and have plan sheets. Okay. Not talking about stationing. A station is the horizontal measurement along a survey center line of a project, and here you can see that's at 610 here. You have tick marks, and these tick marks run every 100 feet until you get to a major stationing line. Then they're every 500 feet apart. You also see on plan sheets, you'll see some curve data. Over here you can see curve data. If there's a curve on the project, you're going to see that it's going to have the PI listed. It's going to have the length of the curve. It's going to have information, and we'll go over the curve data later on. You also see if there's a station equation, you're going to see it on the plan sheets as well. In this case here, it says that station 608 plus 01.01 is now going to be station 608 plus 00. So they wanted to even that station out from this point on. Okay, so that's why they do it, and we'll talk more about equations later on. You'll also see that you get bearings on your tangents. So there's no curve here, so you're going to see a bearing, and this one says it's going south 34 degrees east, okay, or 34 degrees 57 minutes 33 seconds east. Down here you'll see a tangent spiral stationing, which is TS for the tangent spiral, and it'll tell you where it's happening at, what the station is. And when you have an equation, you end up having a region 1 before it, and after the equation you have a region 2, and that's what that R2 stands for in this case. Now, horizontal curve. What is a horizontal curve, and what goes on with it? We'll just go through this. This is the curve right here, coming through here, but all this other stuff builds that curve. So let's go through it. First, you have your radius of the curve, which is your R. Okay, so that's the radius. Then you have your length of curve, which is along that curve, the length of the curve along the curve. Then you have the long chord, or chord, which is the length right across that curve. Then you have point of curvature, and this is your beginning point. So you got a tangent section coming in. So we're coming in a straightaway. We got a bearing, whatever that might be. It might be north 45 east or whatever. But you're coming in, and when you hit this point, that's your point of curvature. That's the beginning point of your curve. And then you have the point of intersection, which takes the PC and the PT and intersects that, and that's your point of intersection. And then you'll have your PT, which is point of tangency. So you go into your curve, and you go along that curve, and you come out of the curve. That's your point of tangency. Now you're going into the next tangent. Okay, so that's what that does for you. Now the PI is the intersecting point of those 2 points. And then you have the tangent distance between the PC, PI, and the PI to PT. Okay, so that's basically the nomenclature of a curve. And the intersection angle. My bad, forgot that. So some common features that you see, and some of these we'll look closer at, but here's stationing again. And this is a better example of seeing how it works. So we're at 1720, here's 1725, major station marks. If we was to see it, you can see it here, the major tick marks go across the roadway, across that alignment. Okay, so you see majors are across. The minors are half tick marks. So what you get is, here's a major, and you get 1, 2, 3, 4, 5. So 100 foot in between each one of the little tick marks, 500 into the big tick marks between each one. So that's what that distance represents. Next, you'll have a property owner. Okay, so you'll see a property owner. Normally you'll have a number. It may be on a completely different sheet. Sometimes they put them on a different sheet, but you'll see a number out there, and you can go to that other sheet and find out who the property owner is. But sometimes you'll see them on the sheet. Right-of-way symbols, whatever type of right-of-way is being used out there. I could tell this is proposed or new right-of-way that we're acquiring because it has a filled magenta cross on there, or Maltese cross. Okay. You'll also see property connectors. So instead of putting a name here and over here on that plan sheet where it makes it really jumbled with a lot of information, they put these little Z's on there to tie one property to the other. So that they got listed over here, they put that little tie, that property tie or connector to the next property, and that lets everybody know that's looking at the sheet that they own this property and that property. Same with down here with City of Clarence. They own both sides. Bearings, again, that's when you're not in a curve situation, where you're in a tangent situation. So we're running north, whatever, east on that one. Looks like 79, but I couldn't tell you. And then utilities. You have your utilities that'll be on plan sheets. In this case here, we have storm sewer line coming across here, and it looks like it's new storm sewer line coming because it would have a line through the SS if it was existing. Let's see, is that it on this one? Yes, it is. More information on the right-of-way symbols with stations and offsets. So usually what you'll see is wherever there's a bend in the right-of-way, you'll never see curves on right-of-way. You'll always see bends to them. You'll see the property line, the right-of-way line out here. You'll see the symbol, what it represents, and then you'll see some stations and offsets from the center line. It's going to say at 623 plus 49 at an offset of 198 foot is where this point is. And the same with this one. You'll come down and look at that, and it's labeled with a station and an offset to let us know how far off that center line it is, for one, and how far along that center line it is in that station range. And you'll get the same with the last one. If you look at the and that's what this one is, fully controlled, you come down here and you can see that those double Maltese crosses actually represent temporary access through future no right-of-way access. Okay. Now some more stuff that you'll see on plan sheets is drainage, and this sheet is a lot of drainage going on. You can kind of see some stuff out here. Let me go ahead and click the button, and you'll see we have drop inlets everywhere. There's drop inlets all over, and I don't think I even circled all of them. There's more in here. They'll be designated usually by a DI and then the number. In this case, they use just a D for it, and you'll see like D5 here. And if you look at D5, you'll see the notes off on the side. It'll tell you what it is, a precast type D drop inlet, and it usually tells you what type of pipe and all kinds of information on that. So this is what the drop inlets look like. You'll see them all over the place. And then we have more information on drainage. You'll see a manhole called out with an M. Usually it's MH, sometimes they use M. And then you'll see flared in sections, which is FES is what they'll have out there. So you'll see those. More drainage information. In this case, you'll see where they did a drop inlet 15, and if you go down to look at that D15, you'll see that it has the route it's on, and whether it's on the left or the right side. It'll tell us the precast type, how big it is. It'll also tell us information on that. Let's see, one 15-inch Group A flared in section on the end of it. So that's the information for this part is all in a block off on the side. Okay, symbols to know. Center line. Oh, preview. Center line is this center line Route 5 up here, you'll see a CL Route 5. Property line, you'll see, is PL over here, and usually it'll have a solid line through it for proposed and dashed if it's existing property line. A benchmark looks like this icon right here, the BM with the circle and the X in it. Okay, a fence is over here, and you'll see there's either a woven or a chain link. Woven is the V and chain link is the X. And then you have utilities, and this ain't all of them, but this is just to give you an idea. Again, if it's open like this one, it's proposed. If it has the lines through them, it's existing. Okay, so you see storm sewer, sanitary sewer is just an S, fiber optics, cable TV. Then you have drainage flow. Drainage flow is represented by these arrows. Okay, so wherever you see a creek bed or something like that, or a ditch even, you'll see these drainage flows, which is telling us what direction it's flowing. And then you'll have curve data, and we kind of went through the curve data nomenclature on it, but on a piece of curve data out on a plan sheet, most of the time you're going to see the PI, what station it's at, the point of curvature, which is the beginning point going into that curve, what station it's at, the point of tangency, which is the point where it's coming out of the curve going into the tangency, you'll have that station. You'll have your delta, you'll have your length, you'll have your radius, all that information in the curve data. Bearings. There's a handout in the handout section that you can look at. It shows the direction of tangent sections of the roadway. Been kind of talking a little bit about it. Bearings are measured either clockwise or counterclockwise from north and south, and they vary from 0 to 90 degrees and require 2 letters and a numerical value. In this case, it says here north 60 degrees east or south 30 degrees west. Okay, so north 60 degrees east, if you're looking at this, it'd be right in this area here. So we're going from 0, it would actually 60 be down here. So north 60 degrees east would be right here, coming across there. Now if you look at this example below, you can see that we have a tangent out here. It's running at 0, 4 degrees, 38 seconds, or 38, yes, 38, 0 degrees, 4 minutes, 38 seconds east. So you see the north arrow. So this line is going this way, and it's just a hair off. Not even a full degree, but 4 minutes, 38 seconds to the east, which would be this way. Stationing refers to a system of measuring distances along a designated reference line, usually the center line of a roadway or project. Now, I got this in here to reinforce some of the stationing that we've been talking about, because it is an important part of reading plan sheets. To precisely locate points on a site using a standardized unit like station, where each station represents a set distance, typically 100 feet, this will allow for accurately locating features along the project area with numerical coordinates based on their position relative to the starting point. Sometimes a simple plus will be given. Okay, so in this example, you can see down here, here's a plus station, a fence, which is $7.99 plus 0. How do we know it's $7.99? We got to look at it. It just says plus 00 begin fence. Could have probably put the $7.99 in there and made it less confusing. But if you don't have that, you just want to read the tick marks. So here's the main tick mark. Every 500 feet, 800 foot, it says 800 plus 00 is what this is. So we go down to our major tick mark. We go back one, and that would make it $7.99. And this says 0, so it's right on that, $7.99 plus 00, and that's how they get the $7.99 and just put the plus 00 in there. In theory, I'd rather see the $7.99, but in this case, they didn't do that. Okay, so again, major tick mark, 1, 2, 3, 4, 500 feet down to your next major tick mark. So 795, 500 is 800. Each one in between is 100. So 795, 796, 97, 798, 799. So you can count it however you want. Going back one or going from 795 up. That's how you find your plus stationing. Okay. Station equation. Now, if things wasn't cloudy enough, let's make it even cloudier. Station equations are used particularly in road design to adjust the stationing, the numerical reference points along an alignment. This is where the single station location with 2 stations happens. And when there is a need to change the reference point and account for existing features or modify the length of a project section, a station equation essentially allows for a seamless transition between different parts of a project with potentially different stationing systems. This can include situations like connecting to an existing road with a different stationing scheme, adjusting for a change in the alignment, or incorporating specific survey data. So a lot of times, in this case, it's kind of goofy, but you have a back stationing, which in this case, at this point down here in this station, right here, that I have highlighted, it is 44 plus 49.79 back. So that's back. Ahead, they're going to change that stationing from 44 plus 49 to now represent where they're tying in somewhere else to 7 plus 33.02. So this point has two stationings. It has this one and it has that one, but it's telling you back is this station range. Going forward, we're going to use 7 plus 33.02. And the reasons we're doing that, a lot of different reasons, but normally tying into existing plans, existing alignment with stationing. Alignment data. Again, there's more handouts on this in the handout section. Again, tangents are straight sections of roadway with a bearing. Curves we have are simple or spiral. PC is the start of the curve. PI is the intersection point. PT is the end of the curve. Right-of-way markers are generally found at these points, left and right of the center line. So you can see here, one curve starts here, PC station, whatever that station is, starts right here. We start that curve right there. And then here's another one where the curve ends. You can see this is the PT. So we're coming out of that curve, boop, into a bearing, which means that's a tangent section, a straightaway. Okay, so that's how that works. Right-of-way and easements. There's more again of this in the handouts. Right-of-way property is property we acquire and hold. Easements, they're temporary or permanent. Temporary property we gain access to, but do not own, generally for construction, drainage, or utility purposes. Permanent is property we gain access to and maintain the rights to, such as permanent drainage easements to clean out a culvert or whatnot. And these are kind of the symbols. Again, existing are dashed, open crosses, and new is the solid and filled. Okay. More on the location and surveys can be found in that in the book as well. The section township range on the plan sheets generally located at the top or bottom of the sheet. You can see benchmarks give indication of elevations, known survey locations. So here's a benchmark and it has an elevation down here, it says 686.71. Usually you'll see a little pen out there, or this in this case it says it's chiseled a square in the southwest corner of the wing wall of the westbound bridge. So over Hinkson Bridge, if you're out there at Hinkson Creek at that bridge, you could see that. Meets and bounds are also in the handout, and this is based on known locations such as land survey, monument, uses bearing and direction along with physical features. So in this one you can see that the land survey monument found a 1-inch outside diameter pipe with a cap west of the quarter corner, section 4, township 48 north, range 12 west. Thence the bearing is south 3 degrees 35 minutes 58 seconds west. Okay, and so many feet to station 850. Okay, center line median, I-70, witnessed by the RLS. Now another thing that I try to hammer home, usually you should see Texas section, township, and ranges look like similar to this, where you have the T48 north or the range R12 west or W. But sometimes you'll see them like this. In the older plans you'll see a 243.4, and it's like, okay, so that's your section, township, and range. And that concludes our plan sheets.